Well, welcome everybody to our Westgrid RAC best practices discussion. I'll just give everybody a couple more minutes yet. We haven't quite got to the point of starting yet. We'll still give everybody just a couple more minutes before getting started. Okay, well maybe we can just dive in. So welcome everyone. This is our resource allocation competition sort of best practices talk. I sort of apologize. We're a bit late this year as the RACs are due week Thursday, November 5th. But yeah, we with all the COVID stuff and everything else, we've just been kind of delayed for it, but I hope it's still going to be valuable. And of course, in previous years, I have made physical trips out to most of our member institutions and worked through this, and it's been my opportunity to come and talk to researchers and PIs to see how they're doing, what they're doing, all that kind of thing. It's been great, but of course this year we're not really able to do that, so I'm really kind of missing that. But anyhow, we'll continue on with the best we can in a virtual system. So I'm going to talk about a little bit about Westgrid, a little bit about an introduction, and then talk about RAC and something to do about RAC generally, and then finish up with the RRG, that's the cluster resources for research groups, and then maybe a short break at that point, and then talk about RPP, that's the research platforms and portals system. So there'll be time for questions. I don't think there are a lot usually in these seminars. So yeah, feel free to ask questions as we go along, and we can go from there. Interrupt me to your heart's content, really. Now, these talks, this best practices. I've been working with RAC, with the Resource Allocation Competition, for many years now, both as part of the RAC admin team and as part of the final allocations operation when we review all the science scores and actually come up with our numbers. So I've been working with, in particular, the science reviewers, which are the ones that actually review and score applications. for years. And what I do with these talks is go and talk to those science reviewers, a few of them, and try to hear from them as to what's important about the applications they've looked at. What are good ones, what are not so good ones, what you shouldn't be doing, all those kinds of things. So that's what this talk is based on. It's what I hear from the science reviewers. In practice, quite a lot of it, I think, is pretty standard, good proposal writing. Great. Folks like you have done probably lots more proposals than I have, and have quite some experience here. But hopefully, this kind of talk, looking at the ones specifically about RAC, are worthwhile. So that's what I'm going to do. I'm just going to talk. Say, interrupt me whenever you feel like it. So I think probably everybody's aware of Compute Canada, the federation, and the way it's set up. But here in one slide, of course, we have 4 regions. We have on Atlantic Canada AceNet, Calcul Quebec, Compute Ontario, and then WestGrid for the 4 Western provinces. And in that organization, we have 5 national sites. There's one at the University of Victoria, which has the cloud. There's a very large cluster at SFU in Vancouver. There's another large cluster at the University of Waterloo. There's a very large dedicated parallel machine, a large parallel system in Toronto. And ETS in Quebec has another general purpose cluster. So that's what we've got to work with in a nutshell. And I note there are about 16,000 users now. So the user population is continuing to grow as we go along. I thought I'd just put 2 photos of the WestGrid systems, one at UVic and one at Cedar, but they're all national systems. You can log on and work with any of them, and the allocations we spread across the whole works depending on our load balancing approaches. Our user community, again, just to give you some idea, generally the user population just reflects the actual population in each of the provinces. So BC having the majority of users, and then Alberta, Saskatchewan, and Manitoba. And the research area, again, we're pretty spread across the board here, and that's good for both Compute Canada and for WestGrid. Very similar distributions with our basic sciences, the engineering, math, computer, classic sciences, I should say, physics, astronomy, still our largest users. But we have seen over the last few years a real uptick in things like the humanities, social sciences, environmental sciences, that end of things. And that little graphic down at the bottom says position. Indeed, faculty, students, postdocs are generally our biggest users. And it's always nice to see the faculty actually sitting down and running jobs too. It's not only the students who get the work done, pretty much evenly split. And in WestGrid, about 3,200, 3,300 active users, roles in the whole thing. I wanted to, before getting right into the nitty-gritty, just talk a little bit about WestGrid itself. Of course, WestGrid, we focus a lot on our training and support. Quickly in this slide, there was an online summer school that was completely virtual this year. Of course, all of us have moved to completely virtual teaching, and that took a month. There are workshops, town halls, national support. We answer tickets, and we have support folks across all 4 of the provinces. They are generally situated within their institutions, and in fact, part of institutions, there's kind of a sharing agreement going on there. So there's almost certainly a local support person who knows about RAC, and you can call directly. And 2, I wanted just to mention here is that the online autumn school starts next week. So over a week of courses focused on getting started. You can register. The link is there, and I think we're going to share these slides, so you'll be able to go to those, or you can go to the WestGrid website. And rather interestingly, Westgrid is co-hosting the IEEE Scientific Visualization Contest. That's an international contest where you get to see if you can do something really flashy with a nice data set. And we've helped or worked with IEEE to set up that data set and to get the whole thing going. And it's launching tomorrow. So that's kind of nice. And I thought I would mention it. Right. That's kind of it for a quick introduction. If I was here in person, I would, at each of the sites, I would probably go over in some detail much more about how Westgrid fits within it. But I think for this presentation, we're aiming very much more at the resource allocation committee competition itself. And there's always a bit of a disclaimer here. Yeah, I'm taking my experience, the experience of various of our support folks and analysts, and what I think is going on, and trying to wrap it up. But of course, in practice, if I get it wrong, it's the Compute Canada official documentation that has it, and that's all on the Compute Canada website, www.computecanada.ca. So I suspect everybody's probably aware of this, but just to go over it quickly, the resource allocation competition, the RAC, RAC. So fundamentally, we just don't have enough resources to satisfy demand in Canada. So we need some way of allocating demand, and we set it up as a competition. Now, we are aware in Compute Canada that we have a number of new faculty, smaller projects, those kinds of things that need resources, as well as the major projects that actually apply for a RAC. So our kind of fiducial aim is that about 80% of resources are allocated through the RAC competitive process, and 20% is open to opportunistic use. This changes a bit depending on our resources, how many RACs we get back and forth, but we aim for something like that 80-20 split. And just to note that RAC is open to any researcher or student at a Canadian institution, or at least you can become a Compute Canada user, and you can dive in and start using that 20%. And then if you want, you can go for the 80% and actually submit a RAC. But in that case, you're a faculty member. A few bits and pieces of the RAC allocations. We've got about 175 recipients of RACs in Western Canada. And again, a nice split across all the different disciplines. This slide just accentuates the fact that we really don't have enough resources. On the top there, the Westgrid member RAC recipients last year for RAC 2020, they received 41% of what they asked for, what they requested of compute, 24% of GPUs requested, so GPUs in high demand, but we were actually pretty successful in the way of storage, got almost all the storage that folks requested. And that's pretty consistent with the rest of Compute Canada down in the bottom right. The Compute Canada 40%, 26%, and 86%. So we're pretty consistent across the board there and across the individual institutions. But again, 40% of what we were asked for last year, and it might be better this year since we've got a few more resources, but at the same time, demand is going up. If you want to know some stuff about the value of these allocations, and if you get an allocation, the letter that you get will tell you about what it's worth. And what we do is essentially sum up the raw costs of everything we do, the capital costs and operating costs, and come up with some numbers about what each is worth on average. It's a pretty big average, but it gives you some idea. So all allocations, 32 million, of which Westgrid got about a third of it. Again, not too bad. Westgrid's one of the bigger regions in Canada, so we're doing well. And just to go through some of the actual RAC 2020 results, from WestGrid, we got 186 applications, and of which 181 were successful. That's pretty good. 97% got something. The RRGs, 87, and fast tracks. So I'll talk about fast track shortly. And you can see the breakdown there. Right in the middle, the average science score. So this is, we asked the science reviewers to give a score out of 5. And the WestGrid average is 3.5 out of 5. That's actually exactly what the Compute Canada Federation average is. So we're average. Yeah, and you can just a few extra numbers there: CPU allocations, GPU allocations, and there's that at the bottom is the storage, where we got 43 petabytes of allocated storage, and the Compute Canada Federation was about 100. So so we did well on storage. We got quite a few big storage requests from WestGrid institutions and WestGrid users. Yeah. Okay. So so getting into the process, we have these. Let's see. I think, is there a question there? Okay. So the default is sometimes called RAS. That's the Rapid Access Service, and there are some details, but essentially they mean the same thing. Rapid Access Service, in the sense that anybody can grab an account and start using the resources. So RAS is that 20%, and we've put limits on it. So if you're beneath the limits, then you should not submit a RAC. If you're above the limits, then you can submit a RAC if you want. And I've just written them there, pretty straightforward. They haven't changed much over the years. So compute 50 core years, storage more than 10 terabytes, GPU more than 10 GPU years. And if you're working under that, you can go in the 20%. And cloud services, if you're looking for cloud resources, you can actually get 80 virtual CPUs of compute in the compute partitions. Well, that's quite a lot, really. And persistent 25 and some 10 terabyte storage. So that's pretty straightforward. I think everybody's probably aware of that. And you can apply or not apply, as the case may be. The actual default amounts, I just thought I'd mention this. That's the 20% that we're talking about. So CPU and GPU is opportunistic. We take that 20% and just divide it by the number of active users to get you a priority. So it depends on how many folks are active at any one time as to what the priority is. And if the RAC users, that's my dogs here. If the RAC users are not using up that 80%, then in fact the opportunistic use can bleed over. So we try to make sure that the systems are always 100% used, but the balance there is something that we can play with. Similarly, storage. There's the project storage, which is just what it says. It's allocated storage for a project, usually run by a PI, and you get 1 terabyte automatic, and you can ask for 10. After that, you should ask for a RAC. And nearline is our tape storage, where you can move inactive files off to nearline, and it gets moved off to tape. And similarly for the cloud resources, there are the defaults. You got to ask for the cloud stuff. So if you can ask, and we'll just give it to you without anything further. If you need more than those, then you need a RAC. So the two competitions, the RPP and the RRG. So RPP, that's aimed at scientific gateways. So we want a community of users. It's developing web portals or platforms. Typical things are a big data set with some kind of search engine in front of it. I'll talk about that in more detail, say, in the second part of this presentation. I'm going to concentrate on the RRG in this part of the presentation, mostly because we've got lots of folks doing RRG, and there aren't that many scientific gateways or platforms or portals. And RRG is classic HPC. So that's the big clusters submitting jobs to the big clusters. There's a documentation link, And a quick note right up front is that we do recommend you consult with support staff. So you can send to support at Westgrid or support at Compute Canada or RAC at Compute Canada and ask for us to give you some help with setting up a proposal. This slide is more or less unchanged for a few years now, but just to remind everyone that while we talk about an allocation of, for instance, core years or GPU years, that actually gets translated into a priority. That's a scheduling priority. So when you submit a job to the scheduler computes a priority and decides when it can run your job. And many other things go into a scheduler, like how much did you ask for? Are there spare resources hanging around? Does the scheduler have to clean out some nodes for your jobs? All those kinds of things. So the approach here is that if you do have normal, sort of average jobs in the queue all the time, then pretty much you will get your allocation. If you at some point don't submit any jobs, well, then you lose it. It's still a priority, and if it's not being used, other people can get in there and use it. So keep that in mind, and it's aimed at this continuous use. We've got really quite a lot of users around, so in the end, it balances out. But you cannot hang around for 6 months and then use your whole allocation for another 6 months. And the RAS compute, I think I just mentioned that. It's not really an allocation, it's a priority again, and it's opportunistic in this case. Of course, the cloud is kind of different. If you get your virtual CPUs, that really is an allocation. You get them, you can start them up, and they're yours, and you can do with what you want them. That's an OpenStack infrastructure as a service cloud, and I think we're all kind of used to that at this point. So more on the structure. Again, this slide's kind of unchanged from 2020. We haven't done too much. There's the RRG and RPPs, and just concentrating on RRG, you can have a new application, in which case there's the form and the template, and that goes through the science and technical reviews. If you're continuing, you can elect just to use your results from last year. That's what we call a fast track. Invitations went out in September. There's almost nothing you have to do in that case. You just accept the invitation and send a quick paragraph or two. And I think that's all due tomorrow. So I'm hoping that everybody's got their fast track invitation, those who want to continue and have made use of it. The point there is that you reuse the science score from last year and just stick it into the mix. That is allowed for twice, so a total of 3 years. You can apply RRG 1 year and then do a fast track for the next 2 years. And then we think that you should probably do another one and see what happens. RPP is for 3 years. It's repeating, but otherwise it follows the same kind of approach. Here are the dates. So yeah, fast track tomorrow, but November 5th is the deadline. And unfortunately, since we have a big operation to grab reviewers and allocate the submissions off to the reviewers and get it all done in time for the April 1st beginning of the RAC year, yeah, there's really no extensions or appeal process for the dates. And I put one note at the bottom there. There may be some of you who are doing some COVID research, COVID-related research. We developed a COVID program back, I think it was in May, and asked for applications, and we got not many in the end. Thought we were going to get quite a few more, but at that point, we just gave some resources to whoever asked for it with a minimal review. If you're going to continue to do COVID research starting next April at the beginning of RAC 2021 year, you should ask for it in this RAC submission now. We're not going to continue the original emergency program. So mention it, and of course, if you want to mention it in the science in your proposal description, you should mention COVID-19 and what you're going to do. These are very quick slides. There's the number of applications, and you can see it's just linearly increasing. 590 last year, so we're going to be well up to 600, maybe 700 applications next year, and it's going to be competitive. There are our resources to give you an idea of what we've got available. Cedar, Graham, Beluga, Niagara, and Arbutus. Cedar at SFU, Graham at Waterloo, Beluga in Quebec, and Niagara in Toronto, and the Arbutus Cloud at University of Victoria. I just, in this slide, you read it, but I just want to note that we have bought some more hardware over the last couple of years, and particularly last year, and a whole bunch more GPUs because they're in such high demand. And you will note now that there are multiple types. So keep an eye kind of on that. Which ones are you using? You know, the Pascals, the P100s, and the Voltas, the V100s. And Graham itself has some of the 32-bit T4 GPUs. So you might want to sort of check into that a bit, depending on how you're using them and what you're thinking about doing, and see and be aware that that we've got quite a range of GPUs now. So indeed, the RACs, all the applications are peer-reviewed and scored. There is a set of principles that, scientific excellence of the research project. I'll note that first bullet says of the specific research project. So this came out of a retrospective that we do with the chairs of the peer review committees, and ask them what we should change every year. And they felt that there was really too much in the way of discussion of presentation of the overall science that a project was doing, and that one should focus more on the actual project that was being undertaken rather than the broad picture. So that's kind of new wording, the specific research project. So be aware of that one. Of course, scientific and technical feasibility, that over the years has become more and more important to us, where we ask the reviewers to check the methods, the technologies being proposed. You know, are they the right ones for the research project? And then the appropriateness, have you got a good estimate of what you're asking as resources, and something about whether you're going to use them efficiently. We are certainly seeing that the GPUs are still pretty new to folks, the artificial intelligence, machine learning end of things. And I think researchers are really beginning to learn a bit more about how to use those. So we're kind of looking for efficient use. And every year we have a cutoff score. Last year that was 2.5 out of 5. And just to notice that a 2.5 is still a fair. And we have to have a cutoff that's pretty extreme.
Patrick, there are a couple questions in the chat about cloud resources that I cannot answer. So one is there a breakdown of persistent versus compute resources in the successful allocations? Successful applications.
Yes, absolutely.
Do we have it later in the slides, or?
I think I mentioned that. In the second period when we talk about the RPPs. So I'll mention that there. But yes, there is a breakdown.
Okay. And the second question is: do you know if Arbutus GPUs will be available for the RAC 2021?
The Arbutus GPUs are not formally available. They are there, but we're still learning about how to set up virtual GPUs. So that's going to be ask for them by request, and the cloud team will work on that and see what they can come up with. So no, not officially on the RAC forums, but they are, but by request, and you'll see announcements about that.
Okay, thank you.
Thanks. Yeah, and thanks, Alex. I don't see those. I'm afraid I don't seem to have
I'll pass these to you.
Yeah. Okay. Right, scaling. So they're pretty obvious. There's a science review. The science reviewers give us a science score. There's a big science chairs meeting in February, usually a face-to-face, but I guess not this year, when we meet for days and work through, and the science chairs tell us what they've come up with and discuss any particular cases. We come up with a scaling function. so that we can fit the in particular the CPU and GPU asks within the available resources, and that's applied to the asks. That cutoff scores increasing. In RAC 2019, it was 2.3 out of 5. Last year, 2.5 out of 5. I'm expecting a bit, 2.8 something or other this year. And the scaling function, I haven't put down the exact scaling function, but it always looks like something like if you get a 5 out of 5, like you're a Nobel Prize winner, then we give you something like 80% or 82 or 83% of what you asked for. If you get the cutoff score, then the numbers are around 15 or 20% of what you asked for. It's pretty low. We understand that, and we have deep discussions every year about exactly what this scaling function looks like. But overall, it generally looks something like that. So yeah, expect it, and we're competitive. Just one slide on specific changes from 2020. So first off, we got that additional resources, the new GPUs, and there's some new cloud services, object storage, and shared file system. There are new science review committees with 590 and expecting well over 600 applications. The reviewers, each committee was just getting overwhelmed. So we split it up. The evaluation criteria have changed a bit. There's a stronger focus on the feasibility, the computational methods, methodology, etc. And there's a bit of an emphasis on funding sources that kind of takes the place of doing a lot of the science. We want to know that you have some funds and can support the project. And again, just a response from the reviewers that the 10 pages that we used to have was a bit much. Could we cut it down to 8? So we've done that over the years, cut it down farther and farther. I think that's about the minimum that we've got. And no out of round. Here are the committees. So used to have 7, got 10 of them now, and in particular engineering, neurosciences, medical imaging, medical physics, and subatomic physics set up as separate committees to handle theirs. Overall, I think the Compute Canada has now about 90 reviewers, so it's a big effort. Right, I've got some general comments now for the rest of this hour. And say a lot of this is just a good proposal creation. How do you write the things, and what do you work with? So I suspect not a lot of this is going to be new. It's very similar to what I've said over the last few years, but always good to be sensitized or resensitized to it. And of course, new folks may find this more valuable. So a couple of little admin details. The page limits are enforced. You have to submit a PDF. And there is, I think there has been for the last 2 years, 3 years, ability for a secondary contact person. That's really good. If the approach we take is that there are actually 2 reviews. One is the science review, which does the scoring and the competitive process. But our analysts also undertake a technical review of any proposal. That's mostly to ensure consistency, to ensure it makes sense. But the tech folks can reach out if they find something is not understood or needs some clarity, and they will call up. And in many cases, the PI, the primary contact, is maybe away or out for Christmas or something. So having a secondary contact is really good. Plus, the secondary contact is also used for any admin purposes during the application. So a really good idea to have that. And there's a straight comment at the bottom in green from a reviewer. Yeah, it seems necessary to continuously emphasize to applicants to closely follow the instructions, including page limits. So I'm sure some of you have acted as reviewers, and yeah, when applicants get a bit carried away, that's a real pain. So try to keep it into within the limits. There's no appeal process. I mentioned that. You need to get it right the first time. Now, you are, of course, writing for the reviewers. Again, one of those obvious points. It's a good idea to know something about the reviewers. The committees are described on the RAC pages, so you can have a look there, probably worthwhile. And the points I'm going to make here, which again come from our reviewers directly, note that we, even though we have 90 reviewers, there's not going to be an expert in every single subdiscipline or area or whatever. They're experts in the discipline, but not necessarily experts in that particular project's focus. And we got this huge range of RAC proposals. This is advanced research computing, so right from the digital humanities to theoretical physics and black hole simulations. So yeah, 90 reviewers don't get spread pretty thinly. So you have to assume that that a reviewer knows the overall discipline, probably knows quite a lot about numerical and computational methods, but doesn't necessarily know exactly what your particular project is. So the point there: avoid lots of detailed jargon. Write for a discipline area expert, but not for the specific areas. And I have certainly seen proposals where the proposal dives into technical details almost instantaneously, and a science reviewer just comes up really not understanding much about what's trying to be done. And the other way around too. Some of them written at a very general level and spent most of the valuable page limit on just describing sort of where your science fits within the whole discipline. So finding a middle ground is pretty important here for the kind of reviewers we've got. So okay.
There are a few questions
yes,
in the chat, so I think we should address these. So
yes.
Brad from EBC is asking how to prevent everyone from just doubling their request, knowing that we usually give just half of the requested allocation.
I got a slide about that.
Okay.
Yes. The quick answer, Brad, is that the reviewers know what they're doing, and they are sensitive to this issue. So okay, next question.
Okay, next question is, are there any guidelines for formatting, font size, line spacing, etc., knowing that I have to fit everything to 8 pages?
Yes, there are, and they are on the website, so I won't go over that, but have a look at the website.
Okay. Does each review committee committee member have their individual quota of resource allocations?
No. It all goes into the mix, and we end up with the scores for the whole works. We don't split it up individually.
Okay, good. Yeah. That's all for now.
Yeah, thanks, Alex. SNSA, keep feeling free to jump in there. Here's another one of those ones that just keeps coming up from the reviewers. Use the templates. There are templates for RRG and RPP. Each one comes in a Word and a LaTeX form. Use whichever one, but those are good ideas. You can certainly work, customize, play with it. We do understand that every project is different in this huge wide range. So one template won't work for everybody, but certainly if you can stay within the basic outline in the templates, that'd be a good idea. And I'll be going through the RRG template in some detail shortly. And here's another one. There's that in green at the bottom, the quote, please improve the motivation of why the proposed calculations are important. So again, trying to find that middle ground between telling us exactly what your calculations are going to be and actually fitting it into some kind of a goal or objective or research goals. So yeah, address the evaluation criteria and justify what you're doing. Only got a few pages to do it in, so needs to be pretty succinct, but of course that's what you're trying to do in the end, justifying your request. That fourth bullet point, I think there is actually in the templates a references section, and you can write down references, papers, things that you think are important there, which doesn't actually account against the page limit, so that's kind of nice. And that last bullet point, poor proposals, generally write a lot, but don't actually provide much in the way of good information. Or there's a really annoying mix. They don't follow the templates very well, and the technical components are mixed up in the description of the research itself, and that turns out just to be hard for reviewers to try to pull out what you're actually asking for. There's the slide about over asks. 2 comments, requests that are obviously too large, that should not over ask. And yeah, the reviewers know about this, and they are asked to have a look at that. And we have occasionally explicitly cut down some requests which were so clearly way above what they should be, and also, if one's not reasonably detailed with a few tables and such, showing that you are planning for your resource use, like how many runs are you going to make, and about how much memory does each run take. I'll go over some of that separately, but if you don't put those breakdowns in, then you get a low score. That's not considered well by the reviewers. So two things here. First off, the reviewers really look for this, but secondly, you are going to describe as much detail as you can how you came up with the requests, and it starts to become pretty obvious. So anyhow, I think, what can I say? In my view, having looked at a lot of these, this happens almost never. Most folks are doing their best. There is an inflation just because we're asking you to look at what's happening next year, and you don't know exactly what you're going to do next year or what grad students you've got, those kind of things. But overall, I think maybe we're just Canada, and folks are doing their best to get to stick within the limits. Any question on that one, Alex?
Yeah, well, Brad just commented, he says, but look, if one knows one needs X to do the science, then you have to ask for twice if you're going to succeed. The applicants know what they're doing too.
That's true, yeah. So try it and see what happens. Maybe, I think most of the time we do catch those kind of things. Okay.
There's another question. Is there support or resources for drafts of RAC applications to be reviewed before submission?
Yes, you can ask us to have a look, and in particular, you can ask your local analyst and send a message to support@westgrid.ca, and we'll try to reach out to you. Yeah, it's a good idea, especially if you're new at this. So another point that comes up is, and it's part of the same thing. Show how much you need. And you'll find all the way through the instructions, there are suggestions for tables to break it out and to show us what you need. So, an example here, which is in section 5.1, is that, somebody's broken it down into different projects and estimated how many core years for each project and how many team members are in the project. And we'll have a paragraph or two to describe that, but the tables are really handy and the reviewers really like it. Concise. Well, yeah, you only got 8 pages. One point that we get actually pretty much every year is that it's very tempting just to reuse, for instance, an NSERC or a CFI application, and that doesn't work so well. Those kinds of funding applications are for funding, not for RAC resources, not for compute resources. So they really don't work very well. And while indeed it's probably a good idea to ask students and postdocs to write part of this, the experienced guiding hand, the PI, the lead, should give the overall structure to the whole thing. One that we get asked for about every year is the Canadian Common CV. That's the CCV, and that's what we use. And so our reviewers have access to your CCV, so keep it up to date. That's where it's got to be. We don't ask for separate ones. And yeah, I think we all understand that CCV, that's not our operation. It's Tri-Council or whatever, but it's not the easiest thing to use. Okay, but keep it up to date. Very important. Yeah, these are just these little points. A narrative. It's really nice. Emphasized by reviewers over and over again. And this is the really, and when you read some of the really top-notch proposals, yeah, what's the science? What's the impact of the science? What are the challenges in setting up a solution? What technologies you're going to use? And then finally, what's the ask? So really nice to have that, and everybody emphasizes it. This one particularly came up of RAC 2020 last year. The forms, the web forms are getting a little complicated, mostly because we just got so many different resources now, the GPUs, the CPUs, the storage, whatever. So it's not that easy to work through some of the forms. And what we found last year was quite a few requests where what was in the form was not what was in the written description. There was an inconsistency. The forms go straight into our master spreadsheet, which is what we all work with. So if it's not right in the forms, we're probably not going to pick it up. And there were quite a few cases where the form, for some reason, had just what looked like a low, quick number, which we actually gave, but the written justification said something much larger, and then we'd get notes after the allocations in March saying, you know, you didn't understand the request. So I'm just going to note this. Try to be careful to make sure that the actual online form and the justifications look about the same.
There's another question. Are there any examples of previously successful RAC applications that we could use as for reference?
Yeah, no, I'm afraid not. We don't have any of those. They're confidential, which is too bad. But any other there, Alex? That was good. Yeah.
Yeah, that's good.
Okay, I'll work through RRG, and let's see, we got about 15 minutes left, and then short break, and then I can do some stuff on RPP. So resources for research groups aimed at the job-based use, and you can ask for cloud stuff in RRG, but that's more for supported computation. So it's aimed very much at the big clusters. The criteria, there are two categories: research methods and resource management. So research methods, that's 70%, and resource management is 30% of the score. So research methods broken down into a few subtopics. So a research outline, and here's, I've taken most of the words here as kind of from the instructions we give to the reviewers. So a well-defined and clear research problem, well-defined and clear goals and objectives, and well-defined and clear deliverables. Yeah, always a problem because you're really looking at the crystal ball for next year, but you gotta tell us as much as you can about what the problem is, what you're trying to achieve, and what the outcomes and the means by which they will be measured. I think that's a little bit of a tough one, but at least if we got some idea of what you're aiming, what papers, theses, grad students, that kind of thing is worthwhile. Relevance, impact, and likely to lead to advances in the research area. The methodology, pretty straightforward, I think. Progress over last year, so a place where you can talk about what you did last year, and then the resource justification itself. And I'll go into some details of the actual form itself, and the template just follows these instructions to the reviewers. Resource management, have you got some funding? And there is a part there. If you don't have any funding, in particular for new faculty, then there is a section there where you can explain what you're going to do about that. Computational expertise of the team and the research and computational expertise. So do you know what you need to do the project, and have you got the right people? And then in some cases, a management strategy that's mostly aimed at larger projects where there may be many components. So here's the template. It's got 8 sections: research outline, expected outcomes, methodology, progress over last year, resource request justification, and that's that first 70%, and then 6, 7, and 8, the funding, expertise, and management strategy. So the template just follows exactly the same approach. So I'll go through a few of the details. So the research outline itself, you got this 1 page, that's a recommended amount. You can mix and match there and cut some down and expand others. But yeah, about a page for the research problem. So make clear the objectives. This is a quote from a previous year where they make clear the objectives is still very germane. The big picture science questions, this year things have focused down a bit more to really what your project is doing. So maybe a little bit of what the science is that you're really trying to fit into it. But that's the part where I think the 10 to 8 pages has changed. And then of course science and the details at whatever level, so that you understand so that the reviewers understand what's going on here. I just have a quick note there again, just to emphasize this slight change, is that I think previous years we call this a research plan, and now it's more a research outline. So keep it a bit shorter. The outcomes, a half a page and a table here is a great thing. Just we've recommended this all the way along. So something about what you're going to do. Are you going to have I put examples there. There's going to be a thesis defense. You're going to implement some machine learning analysis, something like that. And it's nice to see what the outcome is and some small explanation of that to fit in that half page. And again, reviewers kind of like this. They can see it very quickly and see exactly what you're trying to do. Methodology, yeah, half a page isn't enough, I think, but that's about what you got, maybe a bit more, depending on your applications. So yeah, what methods you're going to use, what technologies you're going to use. Sometimes a table is handy in that purpose, but other times you really want to explain a bit more about those methodologies. And I find this one when I read other because I do some of the technical reviews, when I read some of them, that it's hard to find a place that's not too technical but gives enough. So you might want to spend a little bit of time on this one so the reviewer really knows how you're going to do what you're doing. Of course, progress over the last year, pretty obvious. This is the place where you can show your accomplishments and write down something. It's a good idea just to give some background to what you're doing. The resource request justification, this is the critical section, and 3.5 pages, well, 3 pages, 4 pages, whatever, and really what it is that you're going to ask for. So there are 3 sections. The summary at the top, so that's a table, and that's one of the places where you should really be consistent with the form. They compute requests themselves, and yeah, the size of the system, the how big those 5.2.1, 5.2.2, those are topics, headings in the template. You can mix and match a bit about how you want to go through that, and then a separate thing for storage requests. I'll note storage requests are always tough. We cannot scale a storage request. If you're asking for a large data set that you got from some experiment or that you're pulling in and it's 100 terabytes, well, you can't handle half of that. But some storage is from, for instance, simulations where, yeah, if you only run half as many simulations as you propose, well, then you're probably going to use only half the storage. So we have to really look at all these storage requests in quite a lot of detail. It takes a lot of work. And last year I ended up reading tons and tons of these to try to figure out which one was used, which one, where you were going with it. So we keep storage kind of separate here, try to really justify it. So far, we have been able to satisfy that almost 100% of storage requests because we bought extra storage. I don't think we're going to be that lucky this year. So there may be some very difficult decisions to make around storage. So if you really do need storage, be very clear on what you want it for and how much you think you're going to get, you're going to need next year.
There are a couple of questions.
Yeah.
One is, we don't need tons of storage, less than 10 terabytes. Should I even include it into the application?
Yeah, if you're going to do a RAC, do include it. And we get this, sometimes we get applications with a large CPU request, but minimal storage. But it's nice to get it into the RAC in that case, because since it's in the master spreadsheet. And the other way around happens too. We get almost pure storage requests with almost no CPU. And in that case, still ask for the CPU. So yeah, put it all in, just to keep it straightforward.
Another question, if multiple projects require computational resources, what is the suggested strategy? Do I need to write methodology, expected outcome, etc., for individual subprojects separately?
Yeah, it's a good question. Yes, up to a point. You don't have much space. It's a table, and giving some idea of what the what the breakdown is a good idea. And it's so highly dependent on what those sub projects are, and where you're working. So it's nice to have a breakdown if you've got it.
Okay, thanks.
Yeah, can't answer that one too much. I think ask, you can give me a call. Again, note the highlights tables. You feel like just keep coming back to putting in tables. This is important. Tabulate the number and size of the needed runs or jobs or virtual machines. Oh, I forgot that this is section 5.2.2, the compute request. And we know it's difficult to predict usage. If you've got the numbers, great. And there are some projects where some of those big projects where they absolutely know exactly what they're going to run next year. There are others where it's very much a research project. You're developing code and you don't know what you're going to run. So make the point and talk about where there are areas of uncertainty. Oh, and I'll just go back there, that bottom quote, clear explanations of computational needs and costs with details, yet not getting bogged down. Again, finding that balance is what you need to do, and it's hard to find that balance. Here's kind of the table that many folks include. You might say development, you're going to run 10,000 jobs, but each job is going to be 22 hours long and 8 cores per job and 2 gigabyte per core, and that gives you about 200 core years. But then you're going to run some production jobs, and in this case, maybe you're thinking of running 2 of them, and they're going to be very long jobs, 768 hours, and it's a big job, 1,000 cores. Okay, so some kind of breakdown as much as you can do. And here's where, getting back that earlier question, you can't just give us a big number that's twice as big. If these numbers start to look really silly, then it starts to get obvious when you write these tables down. And if you don't have the tables, then the reviewers get upset. Memory, we've been talking about memory for a few years now, that memory is itself a limited resource, and there are a few very fat nodes with large memory per node, and not many. And we're beginning to see, interestingly, I think over the years, more and more of these big memory jobs. So better tell us about memory too, if you got anything out of the ordinary. And usually something like 4 gig per core is a normal amount. And if you're going to get more than that, tell us. And I put the note there that that in fact the scheduler works with core equivalents, which factor in the memory use. So a 1 core job that uses all the memory on a 40 core node, you get charged for using 40 cores because those other cores are not available to anybody else. Anyhow, so include a table which, if you're out of the ordinary, that talks about memory use. Where are we? Oh, well, get a little ways to go here. I'll go a few minutes longer, maybe. So the code details, yes, if you know, this is one where you just want to show the reviewers that you know what you're doing. So what's the code you're going to use, the applications, what's the pipelines, how are you going to do it? Is they serial, are they parallel? What kind of numerical methods? So great, you can, it's nice to have a short section about code details. Performance estimates, remember I said one of the criteria that we have is efficient use. So if you've got them, then tables of performance are, efficiency, scaling charts, all good things. And that's really what one of the things RAS is for. You can go and run your test codes and see if you can get these available. So some of them have it, some of us don't. It depends on the application, and the big pipelines may or may not have these kinds of performance estimates. But if you got them, put them in. They look good. And here's more of the storage end of things but the same idea. What's the use? Nice table. If it's a database, how much do you need? And tell us that you need 100 terabytes for a big database. Generated results, again, yeah, if you're running a bunch of simulations and you're keeping some of the generated results around for a month or 2 months or whatever, and then maybe moving them to nearline. We'd like to know that because that's a different kind of use, and then the nearline, the long-term tape. So whatever you can give us again on the resource justification for storage makes it look good, and tell us what you need. Some folks have given us things like bandwidth and IOPS. Great, if you got them. I don't think we're really expecting to get a lot of that kind of detail, but it's nice, especially if you're IO bound and are worried about that kind of thing. And of course, if you do have particular data security requirements, we have folks who are getting allocations essentially as backups of valuable experimental data. We'd like to know that, and we recommend, of course, that you have a research data management plan and you know exactly what the data is doing in those cases, and talk to us, because we don't offer an archival backup service. We're not 10 nines of reliability on these high performance disk systems. So we're not geared up for that. If you need that, are there security requirements? Is this sensitive data? Do we have to do things around that? So again, that's all very detailed stuff, but you should definitely give us a call if you got that kind of data or expecting to get it. Very quickly here, funding. It's a new table, but tell us about your funding. There's the expertise, and again, what do you need? Do you need machine learning people? Do you need Python people? Are you, whatever the science is, and where are you going to get it? And it's perfectly reasonable. We get ones who say that, yeah, they're in the process of hiring a new postdoc and they might get one. Just gives us some idea of the fact that you've got it organized. That's the idea. And then the management strategy. Big projects, when you got a big team, especially, I put the note up there, required when the team includes more than the PI. Well, if you've got a co-PI, for instance, and you've got 2 or 3 major projects, each with their own set of grad students, how you're going to manage that project starts to become of importance. And you can write down a little bit about that. And some comments there that you better know which students and which doctoral students are doing what, or are aimed at what subject. And again, this is one that I think really aims at the reviewers to make them feel happy that you know exactly what you're doing and that your request is reasonable. Notice that things like these core years GPUs, they're appearing here, they're appearing in the summary, they're appearing in the resource justification. That comes back to trying to make sure everything is consistent. Well, that's a really quick overview, a bunch of ideas and such. There are the addresses. You can, in fact, even RAC at Compute Canada actually gets to the RAC experts in Westgrid. So you can go straight to the central source and it'll get passed on to us. There are guides of all kinds, the templates there. So have a read of all that. There's some frequently asked questions. I don't think that's, some of them are pretty good. And of course, the CCV guide. CCV we always get asked about. It's a pain, but that's run by somebody else. So any questions there, Alex?
Yeah, there are a couple of questions. How does the storage allocation reset at the end of a RAC year?
Yes. What we do, if of course, we hope that you will have a continuing RAC, and then there is no problem. I just note on that one, you must ask for the total storage that you're going to use, not an incremental amount on top of what you're already using. We had some of that issue last year where folks already had 100 terabytes and they'd asked for 10, and we'd give them 10. What they really should have asked for is 110, if that's what they felt the next year was going to do. So ask for the total amounts. If you don't get a RAC and you've already got a ton of storage there, well, you got to take it off. We promise to keep data around, I think, in our policy for, believe it or not, a year. But what we do is send you a message and then try to work with you to move the data to wherever you feel you need to move it. And say we'll keep a copy around, usually a tape copy that's not very accessible, for about a year. So there's some time from early April to whenever you get a chance. So we're not trying to dump on people, but yeah, if storage is limited, we have to get it off our systems. Yeah, I think that's about it.
There are no other questions in the chat right now. Feel free to unmute yourself if you have a question. You can always ask a question by audio if you want.
Yeah, absolutely. Yep. Any questions then? All good. We can expect brilliant Westgrid applications for RRG, and I think we'll probably stop for just a few minutes now, and then I'll go through the RPP application form. So it's about 5 after. I just want to get a drink and things. So how about at 10 after? Does that make sense?
Yes.
Yep. Okay, give us 6 minutes, and then I'll start back up again. Cool. Yeah. Okay. Thanks, everybody, and we'll and those of you who want to stay on and hear a bit more about RPPs, give me a few minutes, and then I'll join in. Okay. Well, welcome everybody again. So continue on. In this one, we're aiming specifically for the research platforms and portals competition. So hopefully most of you were around for the introduction there, so I won't do that again. I'm just going to dive right into the RPP, very similar to what I did with the with RRG, and of course the disclaimer again, just to make sure. So go and look at the official things. Right. So RPPs, the research platforms and portals. We define a research platform or portal as a set of community-developed tools, applications, and data integrated via a gateway. So there's usually a graphical user interface, some specific community. So that's what RPPs are really aimed at. And fundamentally, creating an RPP means that you're going to create this platform in the cloud. You might ask for compute on the big machines, and you might hive off jobs to the big machines if that's part of what your gateway is doing. But fundamentally, there is a web gateway in front of things, and you got a community of users. I note these are 3 years, and but pure compute and pure storage, they should go in RRG. I will very quickly note that that there is an annual report for the 2 years of a 3-year RPP. The notices will get sent in November for those of you who already got RPPs, and it's just a quick review, pretty straightforward. And then we stick the whole thing into the allocation and off we go. Again, no guarantee of an allocation identical to the previous year, but pretty close. And every year we get a few folks who do not submit their annual reports, and we send reminder messages, and then we shut it down. So please submit the report. Another Westgrid point is that we do actually have a small development team, and if you would like some help in actually developing an RPP, if it's a new gateway, then give us a call. There are some resources too within Compute Canada and within the Cloud National Team Support Group. Right, so the details here. Enables communities to develop research projects. So you got to have a user community. It's shared data sets, shared research tools. It's collaborations that RPPs are talking about and what the reviewers will focus on. The place where we see inflation on this one, especially when we first started up with the cloud, is that there are some big ideas out there about how wonderful a platform will actually be, and it'll have 100,000 users within 5 weeks or something. And so take it easy on that. Trying to figure out what your user community is an important part of this, and what's the size of the user community. So those kinds of asks are always pretty critically reviewed, and the allocation may be decreased if the reviewers think that you've been a bit too enthusiastic. We have had one or two the other way around, where a gateway really has been fantastically successful and starts really to increase in usage, and those ask us, and we can see what we can do about helping out on those ones. And the point in pink there, that yeah, if you're developing a big gateway with a user community, you got to have a project team. And it's not necessarily a project team that's focused on the science. It's on developing the gateway. You got to have some science too, but you got to develop, operate, and manage that gateway. So there's a focus around that one. So yeah, the community, what is the user community, what's being provided, and then the development and management. Can you actually develop the your platform? Can you manage it? And are the resources reasonable? I note that at the moment, the cloud that we've got is an infrastructure as a service cloud, an IaaS OpenStack cloud. So it doesn't give much support. You get a bunch of VMs and you can do what you want with them, and storage. So you got to install the operating system. You got to build databases if that's important. You should check for some of the resources. We're building some of those now, and the cloud national team is extremely experienced. And if you really are in the development end of things, it's a very good idea to give them a call and at least to discuss how you build these things. But it does mean that you need your own development team pretty much to start this. I notice Canary has had a program over the summer to provide developer resources with a developer team at a university, at an institution, and the institutions submitted proposals, and I think a few institutions in WestGrid were successful and have developed their own teams. So you might want to check with your institution too to see if there are developer resources available. So the criteria: project justification 50% and resource management 50%. And that shows you the difference with the RRG, that building, maintaining, and managing a big portal is a big effort. And so having the right team is half of the RPP criteria. The project justification, pretty much the same: the description, the objectives, the impact, what you're going to use it for, of course. And there's where one describes the community of users. Outcomes, what are you going to do with it? And of course, progress over last year, which we always asked about. And then the resource request justification itself. Resource management, yeah, same stuff. The team has the sufficient expertise, the management strategy, how you're going to provide access, how are you going to manage users, what technologies you're going to use to do that. And yeah, okay. The RPP template follows exactly the same approach, the justification, the resource management, and works through those subsections. And you got a few more pages in RPPs, since RPPs can be quite large with a number of different objectives, goals. There's a bit more on explaining what you're doing and how you're going to do it. Yeah, some of this is I think pretty straightforward. Of course, what is the platform or portal? What it'll do? So what is the problem that you've seen in the scientific community that the platform needs to address, and what you want that platform to do? That's a pretty obvious one, but of course a key intro to the whole thing, trying to describe that succinctly and briefly, but with some emphasis on why you need that. And yeah, identify the audience. Sure, it can be tough. This is so how many folks do you think might be users of your platform? And that's really that tells the reviewers about, for instance, the scientific worth. If one can talk about the really nifty applications or analysis front ends or whatever that you're going to provide with a RPP, but the key thing here is, are you going to be able to attract people? If you can attract people, then what you've developed is useful. If you're not attracting users, well, then it's not too useful. So emphasizing the audience, who you're aiming for, and anything you can give us about how big that community might be. Of course, if you're asking for resources for a continuing RPP, then you should have all those numbers. Your platform should tell you how many users there are and what they're doing and all that kind of thing. So hopefully you've got that kind of stuff to give us. And yeah, what kinds of research? The last one, sometimes there are actually agreements in place where, for instance, folks like the Atlas High Energy Physics Experiment has already got some international agreements and maybe agreements with the federal government. So we need to know about those if we're, in a sense, obligated to support something in these major projects. Outcomes. Yeah, here we're getting a little bit into project management. What are you actually going to do over the 3 years of the project? I put some, year one, you might assemble a team, develop an architecture, do a proof of concept, and think about key performance indicators or metrics. Year two, well, maybe you got to ingest some data, got to set that ingestion layer up and build a basic searchable interface. And then year three, you're going to build the analytics engine on top of it. So this really is a project plan. Gantt charts, while you never really follow a Gantt chart, at least it shows that you've broken up the problem into its steps and approaches, and it's a pretty concise way of looking at it. So I put that down. A Gantt chart looks good. This really is project management here, or a table, what you're going to do in the few years. So a list of the outcomes, the deliverables, the milestones, and notice how the metrics, the KPI stuff is there. If you're going to build a platform or a portal, you do need to know something about your users and what they're doing and how they're doing it. And if this is a continuing proposal, we really want that information. Is it a successful platform? Is it doing what it's supposed to do? And are you attracting users? And what metrics are you using to measure its performance and success? Yeah, so it's a very, very different kind of project than a RRG working on a science project. Related point here, yeah, if you got a few years, a startup, it's really good to have a phase plan. Some RPPs actually have their own marketing and communications operation, and some of the really biggest one need things like a governance. Who's have you got a consulting board or advisory committee of some sort? Those kinds of things, and developing it. Yeah, you got the team. You got to develop. You got to have developers as well as the science experts doing whatever the science is. And progress over the last year, I've noted that in fact quite a few projects, most projects are actually continuing. They have been successful, and they are providing a service to a user community, and we certainly need to know that in a big way. Is it successful? What's it doing? Where are you getting the stuff? Are your users producing conferences, presenting at conferences, producing papers, all those kinds of things we'd like to know about. And in fact, not only do the reviewers want to see that it's very successful, but I got to say, we as in the Compute Canada folks need to know this, because we are reporting to our funders, and we need to report this kind of thing too. So we'll be asking for this. Yep, and there's the point at the bottom. Yeah, the progress over the past year was not mentioned. Yeah, you should do that, and we've got a specific section now about that. And then there's the same thing we had previously. What about the resources? What resources do you need? And compute. There's a opportunity here to tell us about which compute resources you need, persistent resources, and just maybe to remind you that compute resources are allocated at 1 virtual CPU per core, per physical core. So the idea there is that compute, you use 100% of what you ask for. But a persistent vCPU, that's for the website itself. And of course, the website may only be hit occasionally by somebody accessing the portal, and we over allocate those. So there may be a few virtual cores per physical core. So fundamentally the persistent cloud stuff, that's for the vCPUs that run the web portal, and the compute cloud end, that's for any compute resources you need underneath it. You may hive off jobs or tasks to the compute end of things. And of course, you need storage. The volume and snapshot storage, that's what we're used to. That's the block storage, the drives that you attach to the virtual machines. But the two new ones this year, object storage and shared file system. And I think at the Westgrid Town Hall a couple of weeks ago, we had a presentation from the Cloud National team about that. They're really interesting ways of doing things. Object store becoming more and more prevalent in the cloud environment, and a shared file system if you've got multiple compute cloud VCP virtual machines. Yeah, so keep an eye on that. There are a number of resources here, and again, keep it consistent with the forms. If you write down a table like this, make sure it follows exactly what you put in the forms. And again, it's total requirements. So what's the total volumes storage that you want, and not an increment on what you got last year. And RPPs seem to be a bit more prevalent on that you think you got everything you had for the last 3 years. Now you're putting in a new one, and you just say what you want extra. No, put the totals in.
There's a question in the chat about the accuracy of years 2 and 3 if you're just submitting the application. Can you read it?
Yeah. Yes, the reviewers are aware of this issue. It's hard to predict into year 2 and year 3. That's part of it, is that we'd like to see that plan and the Gantt charts and such. The important part is that year 1, to show that you're really getting used to the that you kind of know what you're doing in building this project. So yeah, the reviewers want to know that you understand what you're trying to build if it's a new project, and so, but we're not going to hold you to it. The things change in these kinds of developments projects. So the year 1 is the important one. I don't think it affects much your chances of success if you leave year 2 and year 3 a bit vaguer, and maybe say subject to the development of something or other, or subject to the community or the availability of data sets. That can be one that we've had before, where data set ingestion runs into issues, for instance, with legal issues, where you think you're going to add a data set in year 2, and you discover that you can't because the folks who hold it won't share it somehow. And we don't kind of go back and cut everything out in year 2 just because of that. But we do understand that there will be some vagueness in predicting too far into the future. Yeah, that was kind of a waffly answer. It depends an awful lot on the project itself too. So yeah, you can give us a call if you'd like, and we can discuss further. Yeah, okay, cloud needs, cloud asks, tables again, as usual, tables. What do you need for the web front end? What do you need for a database server? What do you need for a computational server at the basics? And maybe there are other particular servers that you're thinking of building into the platform. And of course, do you need external IPs too? And so little things, memory and such, is all important too. There is a section called Storage and Compute Resources. And in my view, this section is aimed a little more at if you do need some cluster resources, if you're going to run jobs on the clusters and bring them back again. So I've just put the same table that was in the RRG here. You may or may not then have something here. I think most projects are happy to stay in the cloud and not think about using other resources, but there are some projects who do that. And there were two quick sections here. I just put them both on one slide. So choice of specific resources. Well, generally, you're going to probably run at the UVic, the Arbutus cloud. There are other cloud resources, cloud partitions at the other national sites, and if one seems to be the place you want to run, or you're used to running, or you've already got something going there, then you just note that down. But that's a sentence or two. There is a section about high demand periods. Of course, any gateway platform portal may see periods when there are just a ton of users. So this is a little more of information for us, Compute Canada, about how we think about allocating resources around that. If you're getting very advanced, you might have some load balancing capability, Kubernetes, one of those things sitting around, and it'd be nice to know that your team has the ability to put that in. Most projects, I don't think, have very high demands in the scientific gateway world. They're not YouTube or Google, but if there might be. So I said in the note at the bottom that not particularly required, depends on the particular project, but if it is there, tell us about it. We'd like to know, and maybe we can make some special dispensation for those high demand periods. Of course, existing projects that have been successful certainly may have some feeling for when you get big use, sometimes over the summer, sometimes during, there have been ones where there are particular conferences where for weeks before a conference, suddenly there's a huge demand for for resources just because everybody's going to the same conference. Okay, tell us. Is that a question? Did somebody ask, or is that just a? Yeah. Okay. I think just a hiccup there. And funding, same thing. Most of these big portals, you've got to hire your developers and such. So you've had to go with at submitting a proposal to CFI or somebody, and we'd like to know if you actually got some money to do that kind of thing, and that you got the resources. And say if no funding, especially early stage researchers, that would then be part of the plan, is to say that you've got plans to go for funding for the project. Yeah, that one's. I think if you remember, the default cloud allocation is actually pretty high. 25 vCPUs for persistent will get you. That could really get you started. You might be able to build your portal, at least in its basic form, just using that default. So early stage researchers, folks who haven't really got started yet, probably it's a really good idea to think about just using the default now and getting things started, rather than diving in for a RAC right now. And then all that team stuff. Yeah. Do you need architects? Do you need science leads, dev team lead, JavaScript if you're going to do a front end, and some indication, for instance, if you do want to get one of those Canary funded institutional resources, yeah, that's a good thing to do, and it shows that the institution has supported your project. So yeah, talking about the team, I think if anything more important in the RPP than the RRGs, because yeah, you're really going to develop and maintain and manage a portal. So you need the folks to do that, and you need not only science, you need the developers. And a very similar Section 8, the management strategy, that a really big project you can think of, you might need operations manager, communications groups, an advisory council, those kinds of things. The smaller project or the projects that are getting started, well, you don't need to do too much here. In many cases, a single PI is responsible for pretty much all the management initially, and if you're successful, you'd submit proposals for more funding to hire some of these other capabilities. Well, that was kind of it for RPP. A quick half hour on on the RPPs. I think I just noticed RPP is really very different from RRGs. I think that came through the focus on really developing and managing one of these portals. I've looked at some of the cloud stats that the Cloud National Team guys have been providing, really nice stuff. And you know, the demand is actually increasing pretty much linearly again. There are a number of these, and some of them don't work. It's kind of entrepreneurial. Build a cloud, build a platform, see if the users come, and sometimes it's just not something that users find useful. Either you've built it wrong, or you've or it really doesn't satisfy a need that was a need that was really out there. Other times it can be more than successful. Most of the time, kind of average. Yeah, it's a useful database, useful service, and users are there, and that's great. And we like to track as much of that as we can. So it's kind of interesting. I wasn't quite sure. I think a few years ago when we first started up the cloud, if it would be a success, if there was sufficient demand for building these, but it seems to be there. There are, I think the basics is that there's an awful lot of data out there that you want to share. While we get paranoid a bit about cybersecurity, many of these big research databases are essentially open. And the more folks have access to it, the more studies we can do with it, the better. So yeah, that's really growing. It's kind of nice to see, and it shows. We did in the UVic guys did increase the size significantly over last year, and yeah, just need more resources all the time. Yeah, I think that's about it.
There's a new question. Yeah. The weights between the technical and science for RPP, are they the same as for RRG?
So JJ, is the weighting? I'm trying to think about how the split occurs. Depends on which way you think about what you mean by science and technical. So in an RPP, we're very interested in that user community, and that tells us that the science is good and useful if you got a bunch of users. So in that sense, yeah, about the same. Okay. But we don't ask as much in the RPP specifically about what science is going to happen.
Right. That actually, I know, Pat, we already talked about this a little bit, but it's you know, we have a very large user community that's doing a general area of exploitation, which we can describe. But if we start describing each of their projects, you know, I would need a much longer application.
Yeah, exactly. So and of course, in CanFAR's case, we felt that supplying separate RRGs that would be using RPP was the way to go. Yeah. And yes, so indeed, if you're really successful, fundamentally, I think the answer is come talk to me, and we'll try to find our way through that.
Great.
Yeah, and we're really hoping for a whole bunch more like CanFAR with tons of really successful users.